So first of all, when you want to expand, look at our power. So our power is in power negative 1 over 2. So our n here is equals to negative 1 over 2. When you want to expand using type 2, we must clear what is our n. And then what is the expansion we need here. So actually I want to put star. So the symbol here, I can just only find the diamond. So I put the diamond. And the third thing here is in front here, the first item here must be equals to 1. Here, the red color arrow here must be 1. So I have to look at my questions. My question does not in that pattern, so I have to simplify to that pattern, then only I can start expand using the formula. So first of all, for these 2 plus x power negative half, how I'm going to simplify it. Okay, so I want to make the first item here is 1. So when I want to make this first item is 1, I have to factorize out number 2. But when I factorize out number 2, you bear in mind this 2 is under this power. So when I factorize it out, it is under the same power, negative half. So when you divide it out, factorize 2, the x will become divide 2. Okay, so this is how we take out our numbers. Why we can do that? Because you can see if we using the rules of indices, if this one is cert2 times cert3, we can make it together cert6. If we like cert2 times certx, we can put it together 2x to the power of 1 over 2. So when you want to factorize out value from the bracket here, make sure it is in the same power. So for here, I'm going to factorize the 2 out in order to make this first item is 1. So when I factorize this 2 out, it has to power to negative half. So when I take out 2 means I divide by 2, I get 1. At the same time, this x can need to be divided by 2. So now my pattern will become, my simplified form will become this, 2 to the power of negative half, and then 1 plus x power of negative half. So simplify this, we press the calculator for this, 2 to the power of negative half, it can give us a 2 over 2. So I'm going to expand this form of expansion. I'm going to expand this form of expansion. So we have a coefficient up there, so we just maintain our coefficient. Our coefficient is cert2 over 2, so we're going to expand the rest of it, of this part. So we expand everything here. So in our expansion, what's the information we have? So look at the expansion we have here. Look at the expansion we have here, where n power is negative half, and the things we want to expand here is x over 2. Okay, x over 2. So by using the formula type 2 here, okay, type 2 here, we already identify what is our n, what is our expansion here. So we're using the formula 1, power times the things we want to expansion, then n minus 1 to factorial, the things going to expand square, and then continue the pattern. Okay, so we'll focus on here. We start our formula 1, and then continue n. N is negative half. And the expansion we want to expand here, the star is x over 2. Continue. And n minus 1 divided by 2 factorial. When you see here, we have 2 factor, it divided by 2 factorial, and the things we want to expand also power of 2. So how far we want to expand for it? We follow the questions. They say you can expand up to x power 3. So when you're up to x power 3, you have to stop the expansion. So you need to continue because this is only achieve x to the power of 2, x square only. So I need to continue. And n minus 1 Repeat, n minus 2 divide by 3 factorial, and then here is x over 2 power 3. And then the rest of it, we no need to present, we just put dot dot dot. Means we still have power of 4 divided by 4 factorial, power of 4, power of 5, power of 6, because this is a series of the numbers, it's a pattern of the numbers. But we just present up to x power 3 only. The rest of it we didn't present. We have to follow the question. If question asks us to present up to x power 2, then we will stop here. We will present until this, then we'll put dot 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 and we stop. So this is how we apply our extension binomial for the power which is not positive integers. This is using the formula of type 2. So after we arrange this, after we use our formula, then we continue. So the coefficient sq2 over 2, we leave it. We simplify our expansion here first. So for the first term here it is 1, so nothing to simplify. Then for the second term, we will press calculator. We will press all of this calculator. Just skip the value of x. So means that this we will press 1 negative 1 over 2 times 1 over 2. Okay, so we will press the calculator for second term. Negative 1 over 2, the x we skip it. We put 1 over 2. Then you can get the coefficient. You can get the coefficient here become negative 1 over 4. So this is negative 1 over 4. Then we see the x. Continue. So we'll press for this, negative 1 over 2, negative 1 over 2 minus 1, divide 2 factorial. Don't forget here, we just skip the x only. So this is 1 over 2 square. Okay, 1 over 2 square. And we can get the coefficient. Then only we see our x. Our x is in bracket square, so means this is x squared. And then continue. Okay. Press calculator for this, and this. Divide by 3 factorial, and don't forget this one, 1 over 2 power of 3. Then we can get x cube, dot dot dot. So after we finish all this long expansion here, lastly, then only we expand back our coefficient into the bracket. We have to finish everything. We have to expand everything, complete expand everything. So this coefficient we're going to expand one by one inside here. So just press calculator only. Just press calculator, set 2 over 2 times 1, we get set 2 over 2. Then set 2 times this. Then set 2 times this. I think nothing to simplify here is maintain 3 set 2 over 64. Then continue 5 set 2 over 256. Okay, so we can, so actually this, my coefficient in front here is this. So I take it become this. I press calculator. Why I do like this? Because originally this pattern I cannot use formula. Our formula must be start with 1. That is the criteria of using type 2 formula. So that's why I'm taking the question, then I change to the form that I can expand. So I use the latest form of this pattern, and I start doing my expansion. So because this is start with 1 already, so it means this bracket, this part of this bracket, I can do expansion. So that's why I start with this. So I didn't start with this because this pattern I cannot do expansion, follow the rules of the formula. Okay, so this power and this power 2, we have to simplify. We press our calculator. What is the coefficient actually? Okay, so now we go for the next part. Okay, so this question asks us to expand. We finish our task. Oh yeah, so what is important here? What's the important concept here? Forget to highlight this. What is that? So the first one is how we simplify our expansion. How we change this form to the form that we can expand. Uh, so this is our answer. This is our concept. How to simplify our form that cannot use formula to the form that we can use formula until get this, and then use this latest form of this question that can be expand one. We use it, then we start doing our expansion. So our title of expansion at left hand side, and then benda yang kita nak dah kembang tu ayat panjang-panjang ni at right hand side. So here we going to see your concept, how you put your and, how you put the expansion at startings, how you put this. Then when you get everything correct, we will give you another marks. So finally they say expand. So after I get this expansion, I have to simplify some more the coefficient outside here. So this is my final answer. So this is the five things we can see here. So for part B, before we going to relate this, approximate this value, so we have to find out their validity of the x, find out what is the x value to going to substitute here. This question they didn't give us x value, so we have to find it ourselves. So at the same time, we must make sure our x value is in validation. So first of all, we will do our validity first. Okay, so our validity here, we will refer to the things we expand. What is our star? So our star here is x over 2. So x over 2 modulus have to less than 1. So how we simplify this? We can open our modulus. In chapter 2, this is simple x. Simple x, so it can less than 1, less than negative 1. Then we times 2. So our x value that can make this expansion valid only be using the x value in between negative 2 and 2. If we get the x value outside this range, it cannot be substituted in this expansion. It will become invalid. So after we find our x valid, then we have to going to find what is a suitable value of x that can make our expansion here to become square root of 2 over 3. Okay, so we will try to compare. You can see this is square root, means this is power 1 over 2. So this is also power 1 over 2, but just their power is differ in negative. So I compare first. I compare my expansion, which is 1 plus x over 2 power to negative half, to this value we want to find. This is 2 over 3 power half. So how do I make it same in power? I can inverse it. So when I inverse it, 3 over 2, it will power to negative half. So from here, when their power, they are same already, means 1 plus x over 2 should be equals to 3 over 2. So x over 2 should be 1 over 2, means the x I need to substitute here is 1. So is it this x is valid? So we refer back our validity. Yes, this x can be used safely because it is valid in between negative 2 and 2, means this x can be substituted in our expansion. Okay, so another way we can straight compare. So just now what I compare is I take this valid expansion and compare to my cert 2 over 3. Or I can take my original question, which is 2 plus x power to negative half equals to, okay, again 2 over 3 power to 1 over 2. So same concept, I need to inverse in order to get to same power. Both of them is negative 1 over 2, negative 1 over 2. Then 2 plus x will equal to 3 over 2. So this x will equal to negative half. Okay, so this x also valid. This x also valid. So it means this x also can be used. So just now is x equals to 1, but now is x equals to negative 2. No problem, they will getting the same. So if you're using this 2 plus x and compare, then we will start from here. Expansion is this. If just now you are using x equals to 1, then our expansion will start from here. And then our expansion at the right hand side is this. So depends on the situation. Which one you start? You take this or you take this? Expansion, they are same. Just the form of the pattern here is different. Okay. So, ataupun saya kata, kalau saya start, saya compare yang ini, saya guna bracket yang ini untuk comparekan ke nilai sini, maka nanti saya punya left hand side saya kena tulis ini. Right hand side saya guna expansion ini. Kalau saya tadi guna X yang nilai 1, maka left hand side punya expansion saya akan guna ni. Sec 2 kurungan 1 ni 1 per 2 ni. Dan right hand side expansion masih lagi sama. Just starting procedure tak sama saja. Whether you are using which one. Using this or using this. Okay. So what is the concept we need here is how we find out our X. Make sure our X is valid. If you find out the x is not valid, means your comparison is not in the right way. Okay, so this is how we compare. This is the first mark, which bracket you're going to compare, and then you get same to the value of x in order to find out what is your x, which is valid, invalid, in the range of the valid. So after that, we're going to see how we're going to achieve this value. So once we get our x value, we're going to substitute our x equals to negative half into left hand side and right hand side. So that's why I asked you to write your title of expansion at left hand side. Your result of all this expand at right hand side. So don't put it up and down. When you put it up and down, maybe you confuse what is your left hand side things. So now it is clearly, if I using this negative 1 over 2, my left hand side thing is this title. It is title. So I will going to substitute it in left hand side and right hand side. Means this 2 substitute x negative 1 over 2. I'm using this title because this comparison x is a result from this title. If I using the previous x equals to 1, then I will using this title. And then for the right hand side, we are going to substitute our x negative 1 over 2. Okay, so you must show your step where you need to substitute to the left hand side and right hand side clearly. Yeah, what is your x? Negative 1 over 2, negative 1 over 2, negative 1 over 2. So you have to show out your step here because here is another concept. Another concept. Substitute value, left hand side and right hand side. If you just substitute one side, it won't give you this concept of the marks. So after we substitute this concept, for the right hand side, we will directly press calculator to get decimal. Okay, and for this left hand side, we are going step by step to show how we reach to this number 2 over 3. You have to show it how to reach to 2 over 3. So in bracket here, 22 minus 1 over 2 is supposed to get 3 over 2. So not yet reach to the questions here. So we have to show it one by one for left hand side, step by step. But for this right hand side, we can press calculator in decimal for more decimal because we haven't finished calculate. Okay, so after we press calculator, we get this. Never mind, we give more decimal because we haven't come to the answer yet. Our answer is finding 2 over 3, it's not 3 over 2. So our last step, when we reach this questions, then only we rounding. And then this question, they didn't ask us how much we want to round off. So if they didn't say how much we're going to round off, we have to do our normal concept is using three significant figure. Okay, so this one I have to one more step to go, which is I'm going to inverse it. So inverse it, it becomes negative, negative, positive 1 over 2. Or I can write it clearly. Two over three power negative 1. And then the whole thing power negative half again. Okay, so after I write that, then I come to my final answer already, because negative negative become positive, and power 1 over 2 I can write it as square root 2 over 3 as question asked. So once we reach to the questions uh, problem here, question needed here, we can do our rounding. So although this question doesn't mention how much decimal they want us to do, so we make it at three significant figure. Okay, so three significant figure will be, so you can see I'm doing rounding. So it is approximately. So doing rounding, three significant, 1, 2, 3. So 5, 5. 5, 5 have to round in, become 6. Standard three significant figure. Okay, so here will be another answer. After we substitute, here will be our answer. So here will be our answer, final answer here. So 1, 2, 3, 4, 5. Of course, you also can press your calculator. Just now we press this calculator to get this decimal, right? So we want to have a confidence that is it I'm doing the right thing? Is it I'm doing the right thing? We can double check. We can double check. We just directly press this. When I directly press for this, square root 2 over 3. I get, although my calculator give me a cert number, but I can change it to decimal. I press SD, it gives me 0.81649. So it is a decimal which is near, which is very approximate, which is very close to it. So from here we get the confidence that yeah, I'm doing the X thing correctly. I'm doing this uh, expansion correctly. So that's why when I using this expansion and substitute the value, I can get to the value, get to the square root value. So we can make a double check from your calculator. So calculator, if you press this, it is directly answer. But from here, we are using binomial expansion to get our square root of 2 over 3 to the value. So we are applying the concept of binomial expansion.